A boost regulator is a DC-DC converter whose output voltage is always greater than the input voltage. It uses a switching element to regulate steady DC output of required voltage. I am Reshma, and today we will discuss the operation of a boost regulator in continuous conduction mode. Today we will discuss on boost regulator operation when the switch is turned on, when the switch is turned off, and its duty cycle. As discussed earlier, output voltage is steady DC. The output voltage is always greater than the input voltage. This output voltage is regulated by using a switching element. This can either be a transistor, MOSFET, or an IGBT. When we turn on the switch, energy from the input is stored in the inductor, and when we turn off the switch, energy is stored in the inductor is supplied to the load. Let us assume that the impedance of the switch is almost equal to 0. This means when it is turned on, the voltage across it is 0 volt. Now, if we look at the circuit, we can tell that the input is in parallel with the inductor. Thus, the inductor current starts to rise. Here, the anode of the diode is connected to the ground potential. This is because the switch is turned on. The cathode of the diode is connected to the positive terminal of the output voltage. Thus, the diode is reverse biased and hence it does not conduct. Let us now turn the switch off. The resistance of the switch is high and it acts like an open switch. Now the diode and the ground are no longer connected. We know that an inductor always tries to maintain the same direction of current flow in it. In the circuit too, the inductor tries to maintain the flow of current in the same direction as it was flowing just before turning off the switch. To achieve this, the voltage polarity across the inductor reverses. Now the input and the inductor are in series and the total voltage is the input plus the inductor voltage. Now this voltage is parallel to the diode and the output voltage. This causes the diode to be in forward biased mode and hence the voltage drop across it is forward voltage drop. The inductor current along with the input now flows through the diode to the load. As a result of this, its magnitude starts reducing, or we can see that the current in the inductor starts reducing. However, it should be noted that the direction of the current has not reversed. Let us keep the switch on for time t on and keep the switch off for a duration of t off. Let us keep on repeating this pattern of turn on and turn off. Here, total time is given as t on plus t off. The frequency at which the switch is turned on and off is given as 1 by t total. The ratio of the duration for which the switch is turned on to the total time of operation of the switch is called as duty cycle D. D is given as T on divided by T on plus T off. It can also be written as T on divided by T total. Thus, T on is equal to D into T total. With this equation, we can calculate T off duration. Let us substitute T total as T on plus T off in the equation. On solving it for T off, we get T off is equal to 1 minus T into T total. In this video, we saw how a boost regulator operates when the switch is turned on and when the switch is turned off. We also saw the duty cycle definitions. In our subsequent videos, we will see how to regulate the boost regulator. Until then, let's keep exploring and learning. Thank you.